Welcome back to 3 Inquisitive Kids. In this video, we will be solving for x from this equation. Looking at this equation, we can turn the second term into a similar form as the first one. What I mean by this is, we can factor out a x squared from the second term. If we do this, we will get x squared times 15 minus x over x plus 1. And this gives us 56. We see that we have one part that is repeating, which is this fraction. Because this fraction is pretty complicated, we can use a variable to name it. Let's just call this fraction t. This way, we can just write t instead of having to write a whole fraction every time. So now, we can rewrite our equation as xt squared plus x squared t is equal to 56. Now, looking at this equation, which is much cleaner, we can go ahead and factor out a xt. Doing this, we will have x plus t left in the parentheses. Let's call this equation equation 1. In equation 1, if we get rid of the denominator, so we're going to multiply x plus 1 on both sides, we're going to get xt plus t is equal to 15 minus x. We are doing this so we can find what the value of xt is, and then rewrite it over here. Xt can be represented as 15 minus x minus t. So for this equation, let's just call it equation number 2, we can substitute the value in for xt. It's the same thing as 15 minus x minus t times x plus t is equal to 56. If we look at this, we see that 15 minus x minus t is the same thing as 15 minus x plus t. Here, we see that the expression x plus t repeats multiple times. Because it's an expression, we can just use another variable to represent it as a whole. Let's use the variable a. A can be used to represent x plus t. So we can rewrite equation number 3 as 15 minus a times a is equal to 56. And then we can use the distributive property, 15a minus a squared is equal to 56. So if we rewrite this a little bit, we get a squared minus 15a plus 56 is equal to 0. This is a standard quadratic equation. When we factor this, we have a minus 7 times a minus 8 is equal to 0. This tells us that a can either equal 7 or it can either equal 8. Now, what does a even equal in the first place? How does it help us solve the problem? Remember, we defined a as equal to x plus t. So this is the same thing as saying x plus t is equal to 7 and x plus t is equal to 8. Well then, what does t equal? When we go back, t is equal to this expression. So if we first focus on the first half, x plus 15 minus x over x plus 1 is equal to 7. We can multiply x plus 1 on both sides. X squared plus x plus 15 minus x is equal to 7x plus 7. These two terms cancel out, And we are left with x squared minus 7x plus 8 is equal to 0. Now what about for a is equal to 8? We have x plus 15 minus x over x plus 1 is equal to 8. Again, we multiply x plus 1 on both sides. X squared plus 15 minus x is equal to 8x plus 8. And we are left with x squared minus 8x plus 7 is equal to 0. The final steps is just to factor and solve for x. In the first half, so let's use the formula to find the root of a quadratic. It's negative b plus or minus the square root of b squared minus 4ac over 2a. That's what x equals. And in this case, the b would be the negative 7. So it would be 7 plus or minus the square root of 49 minus 4 times 1 times 8 over 2a, which is just 2. Then we have 7 plus or minus 49 minus 32 is 17. So x is equal to 7 plus or minus the square root of 17 over 2. And now what about the right side? We can factor this to be x minus 1 times x minus 7 is equal to 0. So x can either equal 1 or x can either equal 7. Now looking at this, we have 4 real solutions for x. They are each 1, 7, 7 plus the square root of 17 over 2, and 7 minus the square root of 17 over 2. And these are our 4 answers. Let's go back and review what we did. First, we substituted t for 15 minus x over x plus 1. We did that in order for us to be able to look at the equation with more clarity and be able to find a pattern easier. And later, we also did the same thing when we replaced x plus t with a. And finally, we just unwrapped. It was like onion rings. Like we unwrapped layers and layers and then we got back to what x really is, and we solved for x. I hope you enjoyed this video, and I'll see you in the next one.